In this video, we're going to continue looking at graphing exponential functions, and this is the third of a series of videos. In particular, we're going to look at four potential graphs. So we're going to look at the general exponential function a b to the x, and we realize two things are possible, right? The first thing is, if b is greater than 1, then that means it's an exponential growth function. And it's going to look something like this. And if b is between 0 and 1, then we know it's called an exponential decay function. And it's going to look something like this. But that's when a is greater than 0. So let's think what would happen if a was negative. So if a was negative, a was less than 0, then what you would have is you would have the function flipped. So the function would basically flip over the x-axis like this. And if a was less than 0 here, it would flip over the function like this. So essentially what we're going to do is we're going to have four graphs that I'm going to want you to memorize. So here's the basic model. Y is equal to a b to the x. And first we're going to look at when b is greater than 1 and a is positive. And the way that this is going to be graphed is this is going to be an exponential growth. That's right, b is greater than 1. This will be an exponential growth function. So it's going to have a graph that looks like this. But if a is less than 0, you're going to have exactly the same graph, except it's going to be flipped over the x-axis. Now notice here, this point right here is the point 0a. That's the starting point. Here the starting point is the same, 0a. The asymptote's the same. The asymptote is the line y is equal to 0 in both cases. The only difference is here a starts negative, becomes more negative. Here a is positive, starts more positive. That's when b is greater than 1, when it's exponential growth. And we could give these names. We could call this exponential growth and exponential growth flipped. So let's think about what would happen if you had exponential decay. Exponential decay is when b is between 0 and 1. You have the same asymptote. The asymptote is still y is equal to 0. You have the same starting value, but now you have the value of y decreases as x increases. The y-intercept again is 0a. That's exponential decay, and if it flips, you're going to have asymptote, again, y is equal to 0. The starting value, or the y-intercept, 0a. But this is going to be the graph. It's going to be exponential k, but it's going to be exponential decay flipped. So from this, what you can do is you can pretty easily sketch out what the graph looks like, even if you don't do a table of values. So let's do an example. Let's graph y is equal to minus 10, 1.2 to the x. So first of all, let's just identify if it's exponential growth or decay. Well, let's look at b. Since b is greater than 1, that means it's exponential growth. But a is less than 0, so it flips across the x-axis. So which of the graphs does it look like? In this case, b is greater than 1, a is negative, so the graph looks like this. So the basic form of the graph is going to be that the starting value is 0 minus 10. The asymptote is y is equal to 0. It's exponential, and it's exponential growth, so that means it's going to grow in this direction, and as you go backward, it's going to get closer and closer to y is equal to 0. Now, in order to do a better graph, you're still going to want to do a table of values, and you do the table of values exactly like you did it before. But you notice here you have the asymptote, you have the general shape, and you have the y-intercept before you do anything else. Let's do one more example. Let's graph y is equal to 17, 0.77 to the x. A lot of 7s there. So first of all, is this growth or decay? This is exponential decay. The way that you know it's exponential decay is that b is equal to 0. I'm sorry, b is less than 1. Second, does it flip? A is positive, so it doesn't flip. So let's think briefly what that looks like. Let's look at our 4 graphs. Of our 4 graphs here, we know that b is between 0 and 1, so it's exponential decay. This is where it flips and this doesn't flip. In this particular instance, a is not negative, so this is what your graph looks like right there. So again, before we do any table of values or anything, we know what the starting value is. The starting value is 0.17. The asymptote can be y equals 0. It's going to be exponential decay, so it's going to start from the y-intercept and decay, and it's going to approach y is equal to 0, increase in the other direction. And that's how you graph it. Now, to get a better graph, again, you're going to still do a table of values. But even though you do, that's just going to give you a better sense of what the graph looks like. And that's how you do the basic graphs. And the key thing is to memorize these 4 basic graphs.